I'm here at the offices of Liberty Resources on May 18, 2023 to interview Dr. C. Mark Pearson, who is the company's founder and president and chief executive officer. This is Akiko Billings, operations efficiency engineer with Liberty Energy. Mark, so we get the record straight up front. You've been involved in starting a number of companies with the Liberty name, but your day job is running Liberty Resources. Can you provide some clarity as to what Liberty Resources does?
Sure. Liberty Resources is an independent E&P company backed by private equity investors. We operate in the Bakken of North Dakota, and we've also operated in the Powder River Basin in Wyoming. We currently operate about 15,000 barrels of oil equivalent per day of production, and we currently are running a one-rig continuous drilling program.
And Liberty Energy?
Well, that's the company that you work for. Used to be known as Liberty Oilfield Services, but in 2011 we found that it was easier to start a frack pumping service company to frack our wells than it was to actually get a frack date from the established pumping service companies at that time. And obviously that's a public company now that you work for, and with I believe over 5,000 employees.
Okay, I'm glad we got that straight. Now tell me, where are you from originally, and how did you get excited about the subsurface rock below?
Okay, well, originally I'm from the UK. You can most likely tell from the accent a little bit. It's hard to lose that, even though I've been here over 40 years. When I was in high school, I really liked the sciences. And so in 9th and 10th grade, when you get in the UK system, you get to choose your option subjects. I chose physics, chemistry, biology, and geography, because I just really was interested in rocks and how did this earth that we all live on, how did it come about and how did it get formed? And it just seemed fascinating to me to go do it. So in 11th and 12th grade in the UK system, when you specialize in kind of doing your freshman year type studies, I chose physics and math for the engineering, and I chose geography because of my interest in rocks.
And from there?
Well, from there, I enrolled to study mining engineering at a school called the Camborne School of Mines. It's a small specialist mining engineering school located in southwest England, 180 years old. Originally, it grew up to service the local tin industry. It's now part of the University of Exeter, which is the preeminent university in southwest England and a top 20 rated university in the UK.
Now I know we'll get to the other CSM, as in Colorado School of Mines, a little later, but tell me some more about your studies at Camborne and where you thought you were going after you graduated.
When I was in Camborne, I really enjoyed my undergraduate studies. It was really kind of the application of engineering and a broad scope of engineering to rocks. And whether it was for mining or whether it was for stability and slope stability or underground stability. And I just found it really interesting. And I got the opportunity to go do intern work in the tin mines in Cornwall one summer, and another summer to go to South Africa and work at 10,000 foot depth in the gold mines on the far west of Witwatersrand. So I just found it very interesting at that time.
We're often dealing with oil and gas formations that are 10,000 feet deep, but not many of us have been underground 10,000 feet to actually look and work with the rocks at that depth and stress. Now, you mentioned grad school. What was that about, and why weren't you looking to go straight to grad school following your undergraduate studies?
Well, I graduated with what's called a first-class honors degree in the UK with my Bachelor of Science, and that gave me an automatic opportunity to go to grad school. But I was really interested in trying to understand how we applied what I'd learned at school. And so I had thought through what I wanted to do in my career. And in my management class, our professor had encouraged us to be intentional about our career and the steps that we take in our career. And so what I thought for my first two steps is that I should go out to industry and go and learn how to be a mining engineer, and then maybe come back to grad school for a few years as my second step in my career.
And what were your goals?
Well, as part of kind of our career planning process, our professor encouraged us to kind of think broadly. Unfortunately, I really didn't. When I teach this or give classes about planning your career, I try to get people to think outside the box. Maybe think about running a surf shack in Bali or something fun. In my case, it was somewhat boring. It was to be an executive of a mining or an earth resource company, potentially to go on the consultant side, be a partner in a geotechnical consulting company or something like that. Or thirdly, was to be a professor and to do some consulting work for industry part-time while I was also teaching and doing research work.
Now we'll come back to this theme about planning your career later, but how come you ended up going straight on to grad school?
Well, I wanted to understand operations and understand how to apply the engineering knowledge that I'd obtained. So my first thoughts were to go to industry and to go and spend 2 or 3 years perhaps as a junior engineer working in a mining operation. And the prior year, I'd received a number of job offers from Australia. And so it all sounded very exciting to me that I was going to go to Australia, be a mining engineer. But in 1977, which is the year I graduated, the Australian government banned the export of uranium, threw 25,000 miners out of work, and I couldn't get a work permit. So as I was thinking through what to do, the opportunity arose to go straight on to grad school. And so I decided, why not? Let's just switch it around and go straight to grad school.
So how did your PhD thesis develop and who influenced you?
Well, without a doubt, my biggest influence was my rock mechanics professor, Dr. Tony Batchelor. Tony just recently passed, but was just a great inspiration to me and many other students that he mentored. And Tony just had this ability to show us engineering theory and to take something like, stress through the rock, calculating stresses as a function of distance from a mined opening, and then show you how to turn that into a real application of how did you engineer a structure, or how did you engineer a slope stability in order to be stable. And it just really captivated me, this interest of rocks, but also how to actually engineer principles and how to engineer structures associated with rocks. In the UK system, in your senior year, you have to do an undergraduate thesis, and mine have been how to pump some hydraulic frack jobs on some 100-foot deep boreholes. And there was a research opportunity to work at taking that technology of trying to have a geothermal injection and production system to 1,000-foot deep in granite rocks, and I decided to pursue that and look at different stimulation techniques as part of my PhD thesis.
That sounds fascinating, and you have an interesting photo of one of your first stimulations?
Yes, this photo is a photo of one of the original first near wellbore stimulations. So my thesis was about trying to use small explosive initiations in an open hole granite section in order to crack the rock and overcome the tensile stress or tensile strength of the rock prior to hydraulic extension of the fracks into the natural fracture system. And the reason is because if you just started hydraulic fracturing, the pressure time curve is so slow that all you really end up doing is just opening the natural fractures that already exist. So it was really just looking at near wellbore frac initiation in order to create a geothermal heat exchange reservoir.
I hear you were pretty hands-on the well construction.
Yes, when you're a grad student, you don't have a lot of hands. So the project was to drill 4,000-foot deep vertical wells, frack them with different frack techniques, connect them together, have one injection well, 3 recovery wells. And so I had to oversee the drilling program. I had to design a cementing truck to cement the surface casing of the wells, and then ultimately go and run, the frack treatments, and ultimately the theory of doing all of that became the subject of my PhD thesis.
You also did your first true hydraulic fracturing work there?
Yeah, so as part of the geothermal reservoir characterization, we had the opportunity to bring frack skids from the North Sea onshore. As I recall, there were frack skids from B.J. Hughes and Halliburton that we brought onshore to do our hydraulic frack work and hydraulic circulation work. And we actually ran tests up to 2 weeks continuously of injection and circulation, and looking at the different reservoir parameters and the heat exchange in the granite rock. So it was all very exciting, particularly for a young graduate student.
You also took your first visit to the U.S.
Yes, in 1979, I was given the opportunity to come to the U.S. hot dry rock geothermal program that was being run out of Los Alamos Labs in New Mexico. And their test site was just a little bit north of Los Alamos at a place called Fenton Hill. And I had the opportunity to go there and be on site when they were doing some of their initial frack work with the old Dowell company.
How successful did your own research program turn out to be?
Well, I guess it was pretty successful. We achieved the objective of a geothermal heat exchange reservoir, of connecting the wells together hydraulically through the reservoir. And out of that, we got funding for a much deeper program to drill 2 5,000-foot deep wells that were slant hole wells that would then be stimulated and a geothermal reservoir created. And I agreed to stay on for a year into that program as the lead of the geotechnical group, or the reservoir group, while we put that together. But I'd already set my heart at that point of going to the oil and gas industry, having got into doing frack operations with my graduate research work. I was really inspired to come over to the U.S., what I thought would perhaps be for 5 to 10 years before returning to the North Sea. But that was 40 years ago, and I'm still here, and I don't think I'm ever going back.
From there, you joined Gulf Oil?
Yes, I started with Gulf, and actually started in Canada, with Gulf Canada, working in Calgary. And I worked a tar sands huff and puff pilot. So basically, we're trying to mobilize the in situ bitumen by doing huff and puff steam injection and fracturing of the rocks. And so I joined Gulf in the summer of 1981. And as I got into that program work, spent most of the first quarter of 1982 actually on location in Fort McMurray, working, frack, steam frack, huff and puff injection cycles. So again, pretty exciting, very different obviously than going from a temperate climate in Europe to being minus 40 degrees Fahrenheit in northern Alberta, but very exciting to work with Gulf.
So tell me about your first frack job. I hear it was quite a shock for you.
Yes, it really was. I can say I transferred down to Pittsburgh to work for Gulf Oil US, and my first frack job that I attended, conventional frack job, was in 1982 in the Curtin oil field in Bryan, Texas. And I think you have to recognize, when you're in grad school, we had been running our fracks with a lot of on-site monitoring. We had 3-dimensional accelerometers connected to the granite rock at the surface. So we were actually frack mapping 40 years ago of where the fracks were generating and where they were connecting up. And we had fiber optic cables connecting our on-site data collection to our computers for analysis. And when I got to my first oil field frac job in the Curtin field, we had a Martin Decker pressure gauge that was just a big gauge outside of the frac van that you looked at on the surface. We had a turbine meter that would give you the rate of your clean gel that was being pumped. And we had a densitometer to give us density. And those 3 channels went to a little analog strip recorder that gave you a little kind of 6-inch wide paper strip of the frac job. And that was it. And so it was quite a shock to come and work in the oil field and to sort of look at what conventional fracking was 40 years ago.
Certainly a lot different than our frac monitoring work going on location today. What else work did you do working for Gulf?
Well, when I was at Gulf, my department, I'd originally been hired to work on an oil shale project in Colorado, and that project got shut down as prices dropped in the 80s on oil, and so I ended up working conventional oil opportunities, and my department got transferred from Pittsburgh to Houston, and so I moved to Houston, and I spent a year working a lot of West Texas conventional vertical well fracking, and I also got to work on some special projects. And I guess one of the projects was an assessment of horizontal wells for the Cotton Valley Formation in East Texas. And it was interesting, the reservoir simulation work showed that if we could drill a horizontal well and maybe put 3 to 5 fracks on it, that would be a great production increase and a great increase in recovery if we could do it technically. But we didn't know how we could cement the wells. We didn't know how we'd be able to perforate it and get the fracks to actually turn from longitudinal to orthogonal fracks. And so there were a lot of unknowns, but it was kind of exciting even 40 years ago to dream about what horizontal wells and what multi-stage fracks could do for the industry.
In 1984, Chevron announced they had bought Gulf. How did that affect you?
It was really interesting. As a young engineer, and suddenly I've been working for Gulf for 3 years, and suddenly find out that Chevron had bought Gulf, but they had some antitrust issues that they couldn't relocate people, they couldn't tell people whether they even had a job. And so my whole department, from the division manager to the lowest engineer like myself or a technician, everyone went job hunting, and everyone shared notes about who was hiring, what was going on. And so in 1984, I looked around, looked at various opportunities, and one of the groups that had really inspired me was Atlantic Richfield Company, or ARCO, as they were known. And ARCO had started taking horizontal drilling to the field and had run a number of short radius horizontal wells in fractured limestone formations like the Empire Abo field in New Mexico. And I found an opportunity to get hired into their drilling and completions research group in Plano, Texas.
You spent 7 years in the Technology Center in Plano, Texas. What was your role there?
Well, my official title was a staff research engineer. But we were really given a lot of broad scope in terms of finding opportunities, both to push technology and develop technology, and to then go work with our operating districts on how to apply that technology. So one of the ones that I got into straight away was just on-site monitoring of frac jobs. It was just so rudimentary what most of the industry was doing that we built some trucks, and we built some skids, instrumentation skids, one on the clean side of the blender, one that went on the dirty side of the blender, where we measured real time all the fluid properties, put flow meters into all the additive streams, and then brought it back to our own computer van. And I had a manager that was very innovative. He came up with the idea of naming it the SMART van, and the SMART project, which was a great acronym for Stimulation, Monitoring, and Analysis Research Truck. And so I kind of built this truck that would go out to the operating districts and actually monitor and measure and then model with our frack models what was going on location. Apart from that, I also did a lot of district consulting work, throughout Texas, the Mid-Continent, and other places. So it was an exciting period, and it was an exciting period for the company in particular because while most of the conventional industry was dying, Alaska was growing. 1980s was really the decade of Alaska growth, and ARCO was in a position where they were investing a lot of capital and looking at how to maximize the productivity out of their Alaska resources.
One of your group's projects was drilling the industry's first medium radius horizontal well?
Yes, I'd been hired into their drilling and completions research group, and the group was led by a gentleman by the name of Frank Shue. And Frank is widely regarded as the father of modern horizontal drilling. And one of Frank's projects was that he took directional tools that had been employed in the Gulf Coast, brought them onshore, and went and drilled a 20-degree per 100-foot medium radius well into the Austin Chalk, just outside of Dallas in a place called Rockwall, Texas, as a demonstration of using that technology to land a horizontal well. I believe it was a 1,500-foot lateral in the Austin Chalk that was drilled as the industry's first medium radius horizontal well.
And after that, the tech team took the horizontal drilling technology to West Texas?
Yes, in 1987, we decided to take the horizontal drilling and combine that with fracturing and took it to West Texas to go and run 3 wells as a test pilot program on fracked horizontal wells. Now, these were all open hole laterals, so they were single stage kind of pump and pray fracks that we tried to use chemical diversion on, but about 2,600-foot laterals. And what's interesting is to think about is that this work was going on in the mid to late 1980s, and I think most engineers in the Delaware and the Permian today would think that horizontal drilling, started 10 years ago. That's not the case. It started, 35 years ago now, back in with ARCO, with Mobile, and a couple of other companies that started using horizontal drilling. So it's very exciting. The photo behind me is actually the first well that I was involved with in 1987, which was a large frack treatment of a single 2,600-foot lateral.
And what was the result of these wells?
Well, it was a great technical success. We did everything that we expected to do. Unfortunately, we didn't get the stimulation benefit. I think the well increased about 30 or 40 barrels per month in production, and so it was very minimal, just 1 or 2 barrels a day of additional production that came out of the well, and it was deemed an economic failure and something that the company decided not to pursue.
Now, you also started writing papers for SPE conferences in your early ARCO days.
Yes, in 1986, I remember well my first SPE presentation paper was a paper on spectral gamma ray logging that we were using spectral logging to work out if RA tracer material was inside the wellbore or outside the wellbore, and found that by using a spectral log instead of a total log, we could determine the actual depth of investigation and consequently measure fracture height a lot more accurately. And so my first paper was in New Orleans, ATCE in 1986, and a year later I gave a paper on our SMARTS project on the on-site monitoring, and I think perhaps my favorite paper at the time was a 1988 paper in Dallas that I gave on our Cotton Valley frack work, that I was involved every other Thursday pumping a massive hydraulic frack in the Cotton Valley in East Texas for about an 18-month period in 1985 and 86. where we take our frack crew and our frack equipment from location to location, and every other Thursday we would pump a 3 million pound frack job. But by using fracture pressure analysis, we were able to optimize the designs, get longer half lengths for our fracks, and consequently more production out of the wells. And it was kind of exciting to be involved in a project where we kind of took the technology, applied it, had good on-site monitoring of what we were doing, and consequently changed our designs and got more production out of the wells.
So why were you wanting to publish those early papers, and what was the benefit to you?
Well, first, I had thought that I might be a professor one day. And so recognizing that, I thought it would be a good idea to have some publications and to have my work out in the public domain. But also what I quickly realized is that there's some real benefit when you open your work up to critique and commentary from your industry peers. Just because your company sees it one way or you see something one way, you may be missing some of the analysis. You might be missing what comes out of that. And so there was a great benefit just to be able to discuss my work in an open public forum. And then otherwise, the other point, and I have to admit, was maybe somewhat selfish, that I realized pretty early on that if I wasn't going to publish a paper or go to a conference and present, that I was perhaps going to go to a conference once each 3 or 4 years. And if I wanted to go to the conference and go to the annual technical conference every year, there had to be a justification why the company would send me, and giving a paper is as good a justification as anything else. So I pretty quickly got into sort of the mode of writing one paper a year through my career.
So what other geographic areas did you work while based in Plano?
The company had operations throughout the U.S., so I worked throughout Texas, East Texas, as I mentioned, some in West Texas, South Texas, mid-continent. I got to do a little bit of work in the North Sea out of the UK office, which was nice to get back to the UK, and I actually work out of that office on a couple of projects. I also did some work in Southeast Asia, so and then secondarily Alaska. And since Alaska was 2/3 of the liquids production of the company, I started working more and more in Alaska.
I hear you made quite a name for yourself developing moderate and high permeability techniques in the late 80s and early 90s.
Yeah, it was an interesting time that in the 1970s and early 80s, the leading edge of hydraulic fracturing was really in tight gas rocks. And so a technique that is called the MHF, the massive hydraulic fracture in a vertical well, was kind of the leading edge of how do you do the best MHF work. Pumping 3 million pounds, maybe there are some individual jobs that were as much as 7 or 8 million pounds that were pumped in South Texas. And that was the leading edge of the industry. And no one had really looked at fracking of high perm formations. And a lot of the focus had been on folds of increase. If you look back at a lot of the early literature, you look at the benefit of fracking is that you can get a 3-fold, a 5-fold, a 7-fold increase in production out of a low permeability rock. And that's very true. But if you run the simulation, or the reservoir simulation, on a moderate perm, maybe a 100 millidarcy rock or a 500 millidarcy rock, you realize that fracturing might increase the production 1x, maybe by 50%, maybe 2x if you're lucky. But when you look at the absolute value, instead of taking a 10 barrel a day well and making a 50 barrel a day well, you take a 1,500 barrel a day well and make it a 3,000 barrel a day well. So the absolute impact of moderate and high permeability fracturing was much greater on a per well basis compared to the low permeability fracturing. So in the late 80s and 1990s, as we developed moderate and high perm fracturing for Alaska, for the Kuparuk field, part of the Prudhoe Bay field, and that technology then went on to frac packs in the Gulf of Mexico, what we found is that our designs were really driven by conductivity. So I remember at one time giving a talk about the three most important factors for frac design in high perm formations: conductivity, conductivity, and conductivity. Because if you didn't have that conductivity, you could pump as big a frac as you liked, but you weren't getting any more production than what you would get out of a small frac. So it was an exciting time to be working on new technology and a new application of this 40-year-old technology of hydraulic fracturing.
So you went up to Alaska's North Slope to frack?
Yes, today we call them DFITs, diagnostic fracture injection tests. In the old days, we used to call them data fracs, where we basically pump a small mini frac or data frac into the formation, and then we'd sometimes just shut in the well, sometimes we'd flow it back at a low constant rate, and then we do the fracture diagnostics or the pressure transient diagnostics to work out the leak-off coefficient, to work out off the fracture closure, and design our frac treatments. And so in the spring of 1987, I went up to Alaska with a bunch of equipment from my smart truck, and I remember an old Hewlett-Packard, I think it was called a Series 3 kind of suitcase computer, and went up to go run a whole series of data fracs. What should have taken us maybe 2 weeks to run ended up, because of weather conditions, it took us 10 weeks to run. We have minus 40-degree ambient temperature a lot of the time. I remember at one time fracking with minus 100 wind chill. So it was quite remote and quite extreme to be fracking up there. But nevertheless, we kind of took the diagnostics technology that had been developed for the conventional low perm fracking and started working out how to apply that to Alaska and to high permeability formations.
From there, you worked at optimizing the fracs.
Yes, we increased fracture conductivity and started increasing the size of the fracs. And what we found is that we were able to take the wells from being, having positive skin after drilling to skins of -5 to -6 that would generate flow efficiencies of 250 to 300%. So we were getting 2.5 to 3x what an undamaged flow rate would be out of the wells. And that was pretty significant when you were dealing with wells that you're measuring thousands of barrels a day of production coming out of the wells. So it was very exciting. I did learn one thing. I had a paper in 1992, optimal fracturing of high perm formations, and one of my managers pointed out to me that might be optimum for that period of where we were working it. And sure enough, as technology moves, the optimization changes too. And so that was the last time I remember actually using the term optimization or optimal frac in any of my papers.
From Plano, you moved up to Alaska full-time?
Yeah, I had an opportunity in 1989 to move up to Alaska to join the Kuparic engineering group to work the Kuparic field on drill sites developments. And it was really exciting because every pad we would drill with directional technology. We would drill 16 to 30 wells off the pad, and a Kuparic field, every well was fracked. And so it was kind of a great combination of my fracturing background, but really learning the whole project feasibility and all the project steps and disciplines that go into well development. And so it was a very exciting time of both learning yet still applying my core expertise in well completions.
And eventually into management.
Yes, I had the opportunity to move into engineering management there, but what I realized that technology was really my differentiating contributing factor. And so I still kept chairmanship of a couple of our working groups of technology groups. And the two I chose to spend my time on were our company-wide horizontal well group and also our fracture technology group. So it was, I look back now, 25 years later, it was somewhat fortuitous to both be in management and also still be very involved in the leading edge of fracturing technology and horizontal technology, and ultimately putting those two technologies together.
I know that in 2012 and 2013 you were an SPE Distinguished Lecturer on the 30 years of horizontal well technology development. Tell me more about your early Alaska horizontal wells and what caused you to do this work.
Well, my early Gulf work, I had got involved in horizontal wells from a theoretical standpoint, from a modeling standpoint. At ARCO, I'd been working with, working in Frank Shu's group as he developed the medium radius horizontal well. We tested it unsuccessfully in West Texas. But in 1992, the Society of Petroleum Engineers had a forum on horizontal well completion technology. And the forum format is very interesting at SPE, that they gather a group of 50 to 70 industry experts or knowledgeable people in the industry, and we discuss the state of the technology, and then we kind of think through where could that technology be in 20 years' time. And so in 1992, SPE convened a forum on horizontal well completion technology. In fact, it was in Breckenridge here in Colorado. And I came down from Alaska and participated in that. And we discussed some work that was going on in the North Sea at the time, in the Danfield, in the Danish North Sea. And we discussed some of the other earlier project work in the US. And I went back to Alaska kind of really challenged that maybe there really was an opportunity for us to use horizontal wells in Alaska. And I got approval for a 5-well pilot program in the Kuparuk field where we were going to drill 2,600-foot lateral wells and try and replace 2 vertical wells with a single horizontal well that we'd stimulate by different techniques. And I look back at it now and it kind of seems somewhat rudimentary, but we did, I think 2 of the wells were single-stage fracks, and 2 of them were 2-stage fracks, 1 at the toe, 1 at the heel, to kind of replicate the deviated wells. And 1 of them we actually did a 3-stage frac. But I think what you have to realize is that there was no technology for plugs. There was no plug technology that would withstand the differential pressures that are involved downhole in fracturing. And so we were really limited back then, 25 years ago, by the jewelry or the lack of hardware that we could run the multi-stage fracs. But it was an exciting period. Again, the projects were good, the wells did well, but they weren't better than drilling two conventional wells. So the company didn't pursue it further at that time with just single stage and dual stage fracs, although I have to say I look back at the production results now, and each of those wells have cumed anywhere from 3 to 6 million barrels of oil. So when you look back at over the course of time, really very successful projects.
Why was that so hard to engineer, and why not pump more stages?
Well, as I mentioned just now, that there wasn't the downhole jewelry that we have now, the plugs that can withstand the differential pressures. I remember when we were trying to design it, I think the best packer technology at the time could withstand a 3,000 psi differential pressure. And plugs that we pump today for our multi-stage horizontal fracs are 8,000 to 10,000 psi rated differential pressures. So we just didn't have that technology, and in fact, how we pumped our 2-stage and 3-stage fracs was to use coiled tubing to set sand plugs over the first wells. But it was still very exciting, and kind of we were breaking new ground. And what was kind of interesting is that I remember presenting an SPE paper on it here in Denver at the 1996 annual technical conference, and we presented the results of the 5 wells and what we did. But I think, gosh, there might have been 10 or 20 people in the audience. It just didn't seem to have a lot of interest about horizontal wells and fracking of horizontal wells back 25 years ago.
At ARCO, you received a number of outstanding technical achievement awards. Tell me more about that.
ARCO was a company that really prided itself and really encouraged us to technically take risk, to take steps, to try and do things in a better manner, and to develop more resources, to develop higher value for the company in applying technology. And they celebrated one technology project in each of their business units by looking at the impact of that technology on the corporation's bottom line. And the lead of the project team in each of the companies was then invited to Los Angeles, to the corporate headquarters. I remember going up to I think it was the 51st floor of the ARCO Tower, meeting the chairman, talking about my project and my team's project, because it wasn't just me. I was just fortunate to be leading it. And I was fortunate enough that I received 3 of these technology awards for the impact of the technical work that the team that I was on had made to the corporation's bottom line. And it was a nice way that they celebrated it as well. So I'm very proud of those awards from my time at ARCO.
So after nearly 12 years with ARCO, you left all of a sudden.
Yeah, it was a hard decision. It's been such a great company, and I enjoyed my time, but it was just, I'd lived 7 years full-time in Alaska, and it was just wearing on me. I had hoped to be up there for 5 years, and maybe move on, do something different. After 7 years, it was just wearing on me, just the extended cold and the extended darkness, I think, in the wintertime, or the lack of light in the wintertime. And I was in an operations management position, working 8 days on the North Slope, 6 days off. And I had done that for nearly 2 years, and just decided it was time to do something totally different. And that's when I left and came to Colorado School of Mines as a professor in the petroleum engineering department.
And how was that?
Well, some people in the industry think that it must be a great life being a professor, and it really is. But it's a great life not because of it being an easy job. It's a great life because you're training young people and young minds, and you're giving people an opportunity to participate and contribute in the industry. Because I went in there, had to write 2 new undergraduate courses, and also a new graduate program in well stimulation. I also had to raise money for research work that thankfully, because of my industry contacts, I was able to do. So it was a lot of work for not a lot of pay, I can tell you, but it was very, very fulfilling. Just the students that I met and that have gone on to do great things in the industry, and to participate and to give back to others.
Well, I know you did a great job, because when I went through Mines in 2013, they were still handing out a version of your stimulation manual in the undergraduate senior class. So thank you for that. But you left?
Yes, in the summer of 1997. I had been at Mines for 2 years. I wasn't looking for anything, but I had 3 unsolicited job offers. And of course, oil and gas were in a cyclical industry. And suddenly in 1997, the industry got hot again, and I had 3 unsolicited job offers. I said no to all of them at first, but after some persistence, one company that had recently gone public offered me my first opportunity at an executive position, and I joined a company called Carbo Ceramics that was a manufacturer of premium proppants, ceramic proppants, and other fracture-related services and technologies. And I decided to move back to the Dallas area to go work with Carbo.
Carbo was going through a lot of growth. That must have been exciting.
Yeah, it was. It really was. I got to work a lot of technical projects on fields all around the world on how to optimize completions, how to optimize fracturing. I also got the opportunity to present it to a lot of international SPE sections as part of my job as a VP of Marketing and Technology originally. And I also had oversight of business development, which included building new manufacturing plants, both here in the US, in the state of Georgia, but also in China and in Russia. And that was kind of an interesting experience because it brought some of my mining background in, since you're processing a mined raw material to manufacture an oil field product. So it was an exciting time, a lot of work, a lot of travel, but also a very rewarding time of my career.
So after 5 years as CEO, you left and moved to Colorado to do private equity-backed startups.
Yes, by that time in my career, I had lived in 8 cities in 24 years, and I just felt it was about time to get some stability into my life. And plus, my wife and I were pretty avid snowboarders, and so you can't do a lot of that in Texas. So we actually both came to Breckenridge, Colorado originally, took 3 months off. I actually became a snowboard instructor. It's also, gives you a little, dose of humility when you're earning $13 an hour, plus tips, I should mention, and compared to an oil field salary. And I did that for 3 months, and then came down to Denver to start networking, to start my first E&P company.
And this E&P company was Golden Energy. What did they do?
Yes, so my first company I started was called Golden Energy, named for Golden, where Colorado School of Mines is, as you know. And Golden was a tight gas focused company. And we operated in Wyoming. We also had another project, a horizontal drilling project in the Mississippi Lime in Oklahoma. And I say we operated in the Rock Springs uplift area, just outside of Rock Springs, Wyoming.
I hear things did not end too well.
No, this is a cyclical business. We know that, but often when you're working engineering and technology, you perhaps don't understand the financial impacts of that cyclicality in our business. But we had the misfortune at Golden of working hard for 2 years and starting our first drilling program in Wyoming. It was a 5-well program, and we spud our first well the first week of September of 2008. And I think most of us know what happened. A week later, on September 15th, Lehman Brothers went bankrupt, the global financial crisis occurred, and the wellhead price in Rock Springs went from $6 a 1,000 cubic feet to $2.25 3 months later by the end of the year. And so we were spending all of our capital just knowing that our commodity price was going away. Ultimately, our private equity sponsor decided to go from 6 companies that they had sponsored here in Denver to only 1, and with no hedged production. By June 30th of 2009, Golden Energy was shut down, and unfortunately, Maria and I had lost 1/3 of our net worth in that.
So you closed shop at Golden Energy at the end of June 2009, and what then?
Well, it was obvious that I needed to go back to working oil and oil prospects, and fortunately, the following week, I recall it was, an old ARCO buddy of mine by the name of Scott Wilson. Scott's a VP of engineering at Ryder Scott here in Denver. Scott called me. He had a client that was working in the Bakken and had drilled 2 wells in a new prospective area called the Central Basin. And unfortunately, those wells hadn't turned out too well. They'd only averaged 150 barrels of oil a day in the first month of production. And Scott had been asked to do a reservoir study to look at what was wrong with the reservoir. And his conclusion was There was nothing really wrong with the rocks or the reservoir, but maybe there was something to do with the completion. So I had an opportunity to start a consulting assignment, looking at those wells, looking at offset wells, looking at some refracture treatments that have been done on offset wells. And I pumped my first 2 refract treatments using slick water as the fracturing fluid. And then have 1/3 well and designed what is now the first slick water completion ever pumped in the Bakken, which I pumped in 2009.
The painting on your wall is from a photo taken of you running the frack on that well?
Yes, that was Christmas week, 2009, and my wife and my son William came up to North Dakota with me to go and run the completion of that well. And it took us the whole week to run it. It was very cold, I recall. In fact, it was minus 35 ambient one day. We had to shut down frack operations. It was so cold. But we successfully ran a 15-stage, 1-mile lateral completion.
And when did you know that well was a success?
Well, I remember it well because first week of January, we got to drill out the well, and I was on location as we were drilling it out. And after we drilled it out, again, it was still very cold, so I was in my full Arctic gear from my ARCO days working the North Slope. And that well flowed back 2,000 barrels of oil its first day of production after drill out. And it was kind of an amazing kind of sense of euphoria came over me that I'm here, lower 48, onshore U.S., taking, unconventional shale rock, and we got wells producing 2,000 barrels of oil a day. Not that dissimilar to some of our wells on the North Slope of Alaska. It was quite a realization to achieve that.
That well set a lot of things in motion for you.
Yes, I mean, realizing the opportunity and realizing what would be the economic potential there, it really kind of set me going on raising funds for the first Liberty Resources company, and we were able to raise $200 million for that company, and in September 2010 closed on our first acquisition for that company. So yes, it was exciting. That was really 2010, the start of the Liberty companies.
But as you raised money, put leasehold together, and started drilling, you had problems getting your wells fracked?
Yes, we'd had a number of different frack companies. The whole Bakken was in a boom. There's over 200 rigs running for 5 years, I think, consistently there. Frack services were in short supply. I had brought up a number of frack companies into the basin that had not been operating in North Dakota. But for a small company, as soon as they got work, a bigger company would take them on a dedicated frack contract. And I found ourselves in 2011 in a situation where we had 14 wells in backlog, and I couldn't even get on the frack calendar for a frack date. But I found out about a company that was a frack fabricator in Houston that had just started up, and that it was easier to buy a frack fleet and start a frack company than it was to actually get in the queue and actually get a frack date from an established frack company.
I hear you spent a lot of time in North Dakota in this period.
Yes, it was a period of frantic work and not enough people to go and do everything. So actually, I got a suite at the Candlewood Suites. In fact, it was Suite 408 in the Candlewood Suites next to the old Williston Airport, and we kept that suite for 2.5 years as I rotated with our VP of Ops, 2 weeks on, 2 weeks off, running our frack and completion operations and our production operations during that period.
I know you sold Liberty Resources 1 and now run Liberty Resources 2, but you are still very involved technically in the company.
Yes, it's one of the advantages of being a small company is that I can also, be on our technical teams, and I found that very exciting as we've kind of continued to push completion technology, using tools like data analytics for our completion design, as we've totally changed our perforating strategies. We use a technology that we've published on called extreme limited entry in our perforating for the fracks that we're trying to put into the formation. And now I'm really part of our EOR team trying to really look at, we're about to conduct our third pilot in EOR operations in the Bakken, which I think is very exciting and is really going to be the next phase of unconventional development, because by our estimates, we're perhaps recovering right now 10 to 14% of the oil in place. So there is a massive target out there for technology, and we've got a team working that, and I say we're about to conduct our third pilot for an EOR huff and puff.
In addition to the approximately 60 papers you've written or co-authored and several patents, you've also been very involved with technical committees at SPE, from chairing the JBT editorial committee to chairing numerous technical conference programs. Why be so involved?
Well, it has been great to have such an opportunity with SPE, but at first, as a young engineer, it was an opportunity to learn from others, to go sit in papers, be part of conferences, learn more about the industry than what I was working on directly myself. It was an opportunity to participate in the discussions and to share ideas and discuss those with peers that worked at other companies. As I mentioned earlier, to get feedback on our own work and to maybe view it somewhat differently. And ultimately, as I started working globally to develop a global network here, as SPE International is a global organization, that there's an opportunity to collaborate on a global basis, not just regionally or in the US. And then ultimately, quite frankly, to give back, to participate and to provide opportunities for others to have similar opportunities as myself with SPE.
Is there any one activity that you particularly enjoyed or found particularly satisfying?
I think starting new ventures or new opportunities. I was JPT editorial committee chair at the time when we changed the format of the Journal of Petroleum Technology. We went from just being 3 technical papers to the summaries of papers with 3 different subjects, and typically 3 different papers that are covered in a summary format in the journal. And there was quite a bit of pushback on that, but to me it was all about the core mission of SPE to disseminate technology, and something that I was happy to be involved in. I've also been involved in starting a number of new conferences. I was the program chair of SPE's first International Arctic Technology Conference. I was fortunate enough to be invited on the committee for the first SPE Hydraulic Fracturing Technology Conference, which I want to say was in 2007, was the first one there. And for the first 3 international hydraulic fracturing technology conferences held in Muscat, Oman, I've been the program chair or co-chair for those conferences. And I found that very exciting to be part of new initiatives with SPE.
You've received several awards and recognition from SPE. Any one thing that sticks out in particular?
I think a couple of things. One, because it was totally unexpected. In 2005, I was named as a distinguished member of SPE, and at the time I was CEO at Carbo ceramics, and kind of was more involved for a couple of years on financial matters and corporate matters, and business development. So to be recognized for as a distinguished member there, I was a great honor and something I really appreciated. And I think perhaps more importantly, even than that, perhaps in 2018, I was recognized with the SPE Completion Technology and Optimization Award. I think primarily for my role in completions optimization and completions work for horizontal wells.
In 1994, you were recognized as the Engineer of the Year in Alaska?
Yes, in both 92 and 94, I was actually named the SPE Engineer of the Year in Alaska, which was a great award. But in 1994, the combined 13 engineering societies of Alaska recognized me as the Alaska Engineer of the Year, and it was very prestigious to be so named.
If you were to recommend SBE to a new graduate, what would you tell him or her about it?
Wow, there's so much to SPE, but of course, obviously, the first thing is just the mission of SPE to disseminate technology. And if you want to be a technical person in our industry, there's no better organization to be involved in. Say, an opportunity to learn, to participate, to develop friends, to network together, and ultimately to help you do a better job in what you're working on, and ultimately to contribute to a better society that's really energy driven in terms of our standard of living and our developed society.
What advice would you have for today's young leaders in the engineering profession?
Well, I think first, you've got to be excited. I mean, I was excited by rocks as a teenager, and just fascinated by plate tectonics and depositional systems and so on. And so I think you've got to have a passion. Whatever you want to do in life, have a passion about it, and find what that passion is. And it's going to be different for different people. And so I think first, understand what your passion is. Find out where it fits into the whole energy business and the oil and gas business, and then find a company that needs that passion and needs that understanding and that technology that you're involved with. And then I think a real important element in our industry is that there's very little that we as individuals do. It's teams that make our industry work. That find a team that you plug into that's going to make a difference, that wants to make a difference. And quite frankly, because it's also an expensive industry and it's a capital intensive industry, if you're on the E&P side, make sure that you're with a company that has the finances to actually fund the work that they're going out to go do, because that's so important, particularly in a cyclical industry. There's so many opportunities out there, but definitely I would say that find your niche, find where you're going to make an impact.
Tell me more about some of the career mentoring you've done.
Yes, it's been interesting to develop this concept that I was taught early on by my management professor, trying to be intentional about your career. And so I've had the opportunity to mentor a few groups here in Denver, School of Mines, Colorado Oil and Gas Association, Denver Petroleum Club, to talk about how do you become intentional about planning your career, and kind of conceptually go back to, what's your objective, where you might be at age 50 or thereabouts, and what are the steps that you need to take in terms of developing the experience along the way to make it to what could be your dream job, later in your career. And so, that's something which I've kind of followed in my own career, and it's really helped me, not just in jobs that I've taken and decisions that I've made there, but also decisions that I've made not to take a job, that it wasn't the right thing. And sometimes that's even involved turning down a promotion because it just ultimately was going to lead to a dead end, I felt, and wasn't going to be where my heart was and where I wanted to really participate in the industry.
You even charted your own career?
Yes, here's the plot of the chart of my own career, and kind of broken it down to different steps along the way, and also highlighted the jobs that I didn't take, for a number of reasons. And sometimes those decisions were easy, and sometimes they were relatively hard, I have to say. And I think it's just important as people think about their career that gone are the days where you're going to stay 40 years with the same company, and the only person that's going to really look after your career is yourself. And so you need to know how to think about that. I almost hate to say how to plan your career, but I like to say how to be intentional about your career and you know, how you move and contribute to the industry.
You've been involved in many other startups over the past 10 years.
Yes, I've had the opportunity, being based here in Denver now for I think 17 years, as I've got to know people in the industry, to work with others on a variety of startup companies. Obviously, Liberty Energy, you know, is the largest company that I've been involved with in terms of size. But I've also been involved in a number of technology companies, a cementing company, a wireline company, proppant testing and fluids testing company. So there's a lot of opportunities, I think, as you develop technology, as you stay current with technology, as you get to understand the business. There's opportunities because it is a capital-intensive business. You know, finance people need people that understand the technology, and so I just encourage people that, you know, as you develop your experience in the industry, there's lots of opportunities to participate with smaller companies, particularly startup companies.
Well, you've worked on many projects with many teams over your 40 plus years in the industry. Is there any one project or any one team that was special?
Gosh, you know, when I look back over 40 years, I can genuinely say there's no one team or one project that say that was the defining project. But what I would say at every stage of my career, the teams that I was on, and the teams that I was part of were absolutely right and critical for my involvement at that time. So, you know, if I go back to my early years with Gulf Oil, just a lot of learning. I was just a young engineer being trained by those around me. The same was true when I went to ARCO to start off with, and then I found an opportunity to bring some of my knowledge and some of my frack technology and on-site monitoring and so on to the company and start making a difference in the company's operations. And then using that knowledge to go work with our operations people in Alaska, while at the same time learning a lot from them about drill site development, about production surveillance, about reservoir planning, field development planning, and so on. The opportunity to go teach at School of Mines to really become more of an interdisciplinary group to understand, you know, more facets of engineering, particularly geological engineering, geophysical in some, and different aspects of reservoir and as well as well construction. And then at Carbo, seeing more of a global international service entity and what does it take to be a successful service player in this industry. And then ultimately just doing the private equity here, just being part of teams, kind of pulling all that knowledge together with a lot of great people and enjoying it. You know, having, I would have to say, a lot of fun. It's not that it's fun all the time. I can tell you, 2020, if you would ask me what was the worst time of my career, I can tell you 2020 and 21, or actually I go back to the end of 28 and 2009 after the financial collapse. Those downtimes in the industry can be really tough to get through. But that's when you know you're with a good team, is when you bond together and you pull together and you come through. So no one group that I would say, but just a lot of great teams, and that's what this industry is about. It's about teamwork, and it's about being connected with great teams of people.
And now, are you retiring after Liberty Resources too?
Well, no is the answer. I definitely feel I've got more years to go. Maybe one more E&P company, maybe go back to teaching, maybe just doing startup board work or something, maybe contributing more to SPE. I don't know. There's a variety of things which you could do, but when you are a private equity backed company, you know, there's normally there's a beginning and there's normally a very defined end as the assets get sold or the company gets sold. So you know, at some point here when we exit our assets in the Bakken, I'll be looking for the next opportunity, and next team to work with, and I hope, God willing, to carry on and to continue to contribute.
You've been involved in a lot of key advances and completions for our industry, from on-site monitoring of frac jobs to high-perm fracturing and the whole development of multi-stage horizontal well fracturing. Congratulations on all the projects you've participated in and the achievements of moving our industry to where it is today. I look forward to hearing more the next 10 years of our industry advances, and who knows, maybe your next passion of unconventional EOR will one day become a reality too. Do you have any closing comments?
I feel very blessed for working in this industry and with a lot of great people that have been great co-workers, and many became great friends as well. I say thank you to you for taking time out of your day to come and talk with me today and interview me. And I just commend again that the role of SPE in our society and as a technical institution is just really just has great impact. And I just encourage all the young engineers that are starting off early in your career to really take advantage of the opportunities that you have for both participating in conferences, reading papers, and also getting involved and participating yourself. So thank you.